Hello, chemistry student. Today we're going to be talking about trends or pattern that can be predictable in a way on the periodic table. So first of all, we're just going to talk about the volume of the atom, and the easiest way to talk about relation of volume to reaction is actually the atomic radius. So the atomic radius, the center of the atom from the nucleus to the outermost shell of the electron, changes as you go from top to bottom within a family. Usually, as you go down the family, there's more layers, and the more layers, the radius get bigger. However, contradictory to your, logical prediction, going from left to right, even though the atom is getting heavier, the radius decrease. So as you go from left to right, the radius of the atom decrease. And the reason is, as you go from left to right, you have the same number of layers, but as you go farther to the right, the nucleus is getting bigger and bigger, therefore it's pulling in and it's constricting the outer shell a little bit more. So as you go from left to right, even though they all have the same number of shell, they are getting smaller because the nucleus is getting stronger, pulling the outer shell in. So the atom gets more dense because it's increasing in mass, but it's decreasing in volume. So that one, watch out for it. Specifically, that first bullet point. As you go from left to right, even though it's getting heavier, it is actually getting smaller. Think of it this way. If you're on the left side, it's more like fat, and if you're on the right side, it's more like muscle. Even though muscle weight more, they tend to take up less volume. Okay? So as you go from left to right, once again, the atom actually gets heavier, but at the same time, smaller in radii. And if you go from top to bottom, you're adding layers, so it doesn't matter what family. As you go from top to bottom, you will have a bigger radii. So this picture basically summarizes it. Hydrogen would have a smaller radii than lithium, sodium, potassium, and francium. Same here. Fluorine will have a much smaller atomic radii than astenine. Okay. However, you compare fluorine to lithium, even though fluorine is a lot heavier than lithium, fluorine is actually smaller. So as you go from left to right, it gets smaller, and if you go from right to left, it gets bigger. Now, what is an ion? An ion is just an atom that has tried to become like a noble gas by electronically behaving in a way that is more stable. So atoms that are not in the noble gas family will tend to give away or take electron or share electron in a way that they can have a full valence shell or a full outer shell. When oxygen, for example, has 6 outer electrons and wants to gain 2 more and become 8, it will become an ion with a charge of -2. Sodium has 1 extra electron that you just want to get rid of, so it can drop down to a full shell underneath. So sodium would give away 1 electron, it will have a charge of +1. Please remember, when you give away negative electron, you become positive. Think of it this way, as people become more financially more mature, they will have less bill. And the less bill you have, the more money you actually have, and that's a positive thing. So when you give away electron, it's not negative, it's actually positive, because the electron is a negative thing. The less that you have in your life, the more positive you will be. And when you gain electron, you gain negativity, you will become negative. And you give away electron, you become positive. A lot of people who are quick to jump to conclusion without thinking too deeply, when they hear about giving away electron, they think negative. But sometimes when you give, you can actually become a positive person, like charity work. So same with atom, when you give away negative electron, you become positive. So the ionization energy is the energy it takes for you to try to take away an electron from an atom when it's in a gaseous state, when it's not attached to anything else. So the first ionization energy tend to increase as you move from left to right, because as you go to the right, the nucleus is getting bigger and stronger. It is harder for you to steal an electron from it. Remember, the nucleus is positive, electron are negative, they're attracted to each other. So as you go to the right, the nucleus is getting stronger, the attraction is stronger. It's going to require more energy for you to take away an electron, aka ionize. Don't worry, the next picture will explain everything. So the picture here tells you that, for example, if I want to take away an electron from lithium compared to fluorine, it's going to take, say, 10 units of energy to take an electron away from fluorine, but it might only take 4 or 5 from lithium, because why? Over here, the atom is getting smaller. Remember, the radius is getting smaller. The electron is closer to the nucleus, and therefore the attraction is stronger. You, therefore, when you want to take away something that's attracted to the nucleus, will require more energy. So the energy of ionization tend to increase as you go from left to right. Now as you go from bottom to top, it also increases. Reason why is this one has like 7 layers. If you still want an electron that's so far away from the nucleus is going to have a hard time from taking control of that. But you're taking an electron from a 2 layer or 1 layer, the nucleus is so close to those electrons, as you try to take it, it's going to fight back a lot more because it's easily aware that you're trying to take its electron away. That's kind of a analogy, but technically as you have an atom that's smaller in radius, the more ionization it takes. Because why? This atom has the smallest radius. Electronegativity is kind of like the opposite way of saying how much energy it takes for you to steal something from. Now we're just stating it in a different way. Say it's how much the atom is resisting. So electronegativity is like the ability of an atom to resist you taking away an electron from it. So ionization and electronegativity is the same thing. It's just saying one is the energy it takes to steal, and one is the energy that it's going to try to fight with. But it's the same phenomenon, because if you pull on a string, both hands will feel the same force on it no matter what. So once again, ionization and electronegativity will have the same pattern, just like in the previous slide. But just in case, if you want me to have it summarized nice and neat, here's the pattern. I tend to remember it this way. Atom radius increase the most as you go from the upper right to the lower left. And then atom radius, therefore, is the smallest on the upper right. Okay? Ionization energy and electronegativity, if you look at the arrow, are pointing the opposite direction. So down here where the atom is the biggest, the ionization energy and the electronegativity will be the lowest. Up here where the atom is the smallest, the ionization energy and electronegativity would be the highest. So just remember that as a general rule of thumb. Whichever one that's closer to the lowest left will be the biggest. The one to the upper right will be the smallest. And then the opposite for ionization energy, electronegativity. So where the atom is the biggest down here, it would have the lowest ionization energy or electronegativity. And where the atom is the smallest up here, it will have the highest electronegativity and ionization energy. With that, hope you all have a good day, and please turn in the homework at the bottom of 6.3 PDF section in the book. Okay, the bottom question at the end of 6.3, just answer this question, and that's the homework for 6.3. Just in case you have trouble locating it, it's in our PDF textbook for chapter 6 again, and the question that you have to answer is 20 to 24. So 4 questions. Just once again, write down in your notebook, take a picture of it and submit it. If you happen to take a picture with your phone, download the Canvas app and submit it through that. It will show up. If not, it can have some trouble. If not, just cut and paste a picture onto a blank Google Doc and paste that. Some of you have been typing your stuff up. That's perfectly fine too, and just share that with me on Canvas. Make sure it's viewable by anyone with a link. And once again, with that, have a good day. See y'all on your Sing Meet Day.